Assalamualaikum. Hey, what's up, everyone? So, we are going to tackle something that I see a lot of backend engineers skip over building their own API gateway. Most tutorial will just tell you, oh, just use Core or AWS API gateway or Traffic. And yes, those are great tools. But what happens when your team need custom logic or custom error mapping? A gateway that speak gRPC internally and REST externally. Today I'm going to show you exactly how to build here in Go. We'll use EHO as our HTTP server, protocol buffer as a service contract, and a clear layer architecture so you can maintain in production. No fluff, just code, let's go. By the end of this video, you will have a gateway that takes an HTTP REST request, translates into a gRPC call to a backend service, and sends back a clean JSON response. Practical, right? Let's break down how. Before we write a single line of code, I want to make sure you understand why this architecture is built the way it is. Because if you just copy the code without understanding the reasoning, you will hit a problem you can debug. Let's say you have three microservices and out service, a user service, and order service. All three are the RPC services running internally. Your mobile apps speak REST, your web front end speak REST. How do they talk to the RPC service? You could make every front end speak the RPC natively. Helpful, not practical. You could export each service directly over HTTP. Then every service needs its own out logic, its own course config, its own rate limiting. You end up duplicating the same boilerplate across 5 services, or you put the one thing in the middle that handles all of this. The gateway is the single entry point. Everything public facing goes through here. Your internal services never touch the internet directly. They don't know about HTTP, course, route limit, API key, none of that. They just do their job. This pattern has a name, API Gateway Pattern. It's not new. Kong does it, AWS Gateway does it, Nginx can do it. What we are doing today is building our own lightweight version in Go, so we control every single behavior. Every request doesn't matter what URL, what method pass through here first. Course headers get set. A unique request ID gets stamped. If anything panic downstream, the cover catch it so the server doesn't crash. This is your gateway wide safety net. And I'll look at the path and method and find the matching route. This is where your route path gets matched to your handler. Some routes need extra check before the handler runs. A protected route run check token here. If the token is valid, the request dies here. The handler never runs. If the route is public, this layer is kept entirely. The handler does 4 things in order. Being the request body, validate it, map it to a protostruct called the gRPC service. We'll build this in the next segment. Manage the actual connection to the backend service. Takes the proto request, send it over the wire, data the proto response. Notice there are actually 3 different struct representations of the same data in this flow. The HTTP binding struct, the proto struct, and the response struct. Each layer has its own contract. The gateway is the translator between them. This separation matters in production. If you if your proto changes, say the gRPC service renames a field, you only update the mapping in one place. Your HTTP contract stays stable, your client don't break. Think of middleware as layer of an onion. The request enters from the outermost layer and goes inward. The response comes back outward through the same layers. If any middleware returns ugly, like check token rejecting a bad token, the layers inside it never run. This is important where you're debugging. If request isn't reaching your handler, it means one of the outer layers stop it. You work outward from the handler to find which one. Domain. One folder per service module. Right now we only have out. When you add a user service, you add a user folder here with the same structure. Client, handler, binding. The pattern repeats itself. Proto. The contracts between the gateway and the backend services. Generated code lives here. You never edit these files manually. Root. The routing engine. The get subfolder holds your JSON config. One file per module. Middleware holds your middleware function. Endpoint.go and middleware.go are the registries. Root.go wires everything together. Util. Shared utilities used across the whole gateway. Error types, HTTP status mapping, response formatting, helper function. Nothing business logic specific lives here, only infrastructure concern. Now, the folder structure makes sense. It's not random. Every folder maps directly to a layer in the architecture. When something breaks in production, you know exactly which folder to look in based on where in the request lifecycle the problem happened. We start with the proto file. This is the contract. Think of it like a type API spec, but for gRPC. We're defining two things, our service method and our message type. Notice the field numbers 1, 2, or 3. These are used in the binary encoding. Never use or delete a number once you publish a proto. That's how you break things in production. This generates our Go types. Now we have strongly typed request and response objects and a client interface we can use. Before we build the handler, let's talk about something a lot of people get wrong. Error code mapping. gRPC uses its own status code and HTTP uses different ones. Your gateway needs to translate between them. This is where a lot of gateways produce garbage response like internal server error for a simple invalid credential scenario. We define our own status code as gRPC code constant. Notice we're using familiar HTTP numbers. This is intentional. gRPC has its own code system with value like 0 for OK, 16 for authenticate. Those are fine for pure gRPC system, but we're a gateway. We live between HTTP and gRPC. Using HTTP like a number as our internal standard makes the mapping simpler. Every code has one canonical message. This is your single source of truth for user-facing error text. instead of writing the same string in 5 different handlers, you write it once here. When your product team asks you to change the wording of the authorization or authorized message, you change it in exactly one place. This is the only response shape in the entire gateway. Every single endpoint, such as error, paginate, list, return this struct as JSON. Your front-end and team can write one response parser and it works everywhere. This is the where everything connects. One method call .json C does three things: set any custom headers, call HTTP status for code to get the right HTTP status, write the struct as JSON to the response body. Every handler ends with the return refs.json. Every middleware that rejects a request ends with the return response JSON. Consistent exit point across the entire codebase.
Terima kasih, dadah.
Before we write the handler, look at this struct. This is what comes from the HTTP client. Raw JSON gets decoded into this. The validate tags are the rules. Username is required, password is required, and minimum 6 characters. Email is optional, but if it's there, it must be a valid email format. Our handler will use this to reject bad requests before we even touch gRPC. Let me walk through the import because each one has a specific job. Context for request lifecycle, encoding/JSON for converting between our HTTP struct and proto struct, validator for the validation rules we just saw, echo for the HTTP handler signature, gRPC/status for reading gRPC error details, then our own package, out for the binding struct, client for the gRPC call, PB for the prototypes, and util for response formatter. We embed the validator inside the handler struct so it gets installed once at startup. Not on every request. Function new login is what the router will call when registering this handler. Plain simple. This signature is contract. Every handler in this gateway follows this exact shape. Text and echo context, returns and error. That's what lets our router register any handler generically without knowing what it does. We pull the context from the HTTP request. This carries things like deadlines and cancellation signals. The nil check is a safety net. It practice echo always provides a context, but defensive code is good code, especially in a gateway that handles requests from unknown clients. Bin read the request body and mapped into our login struct using the JSON tags we saw earlier. If the body is completely malformed, not even valid JSON, Bin returns an error here. Notice we return internal error or bad request here. Because a bin failure usually means something is wrong at the infrastructure level, not the user input. Now we validate h.validate.struct r runs through all those validate tags on a login request. If password is missing, if email format is wrong, it catches it all here. We return at 400 level response with the exact error message so the client knows what to fix. The gRPC service never gets called. We save a network round trip. Why push validation is the gateway and not the just let the service handle it? Because your gRPC service might be run in the private network with limited resources. You don't want it spending time on requests you already know are invalid. Here's something interesting. We have two different structures. Outbound login requests from our HTTP layer and pb.login requests from our generated protocol. They have same field names and JSON tags, so we can marshal one to JSON and unmarshal into the order. It's a simple mapping trick. In a more complex system, where field names differ between HTTP and gRPC, you'd write an explicit mapper function. But for cases like this, where they match these roles cleanly, this is the actual gRPC one line. We pass the context and the proto request. We get back a proto response. If the service returns an error, we extract the gRPC status from it. That gives us the error code and message, and we return it as HTTP HTTP status from code, and util automatically convert gRPC 401 to HTTP 401. This mapping table is why our error response are always correct HTTP status code, not random 500s. Happy Pet. We wrap the gRPC response directly into our util.response struct and call .json function C. That format it and writes it to the HTTP response with the correct status code. Done.
Kalau udah bapak, kita gimana kan? Ada bapak? Oh,
That response just traveled through every line of code we just wrote. Build, validate, gRPC call, response, that's your handle working. This JSON file is the brain of our routing system. Each object is one route. Let me walk through each field. The beauty here is that a non-Go developer, a tech lead solution architect, can add a new route or change security just by editing this JSON. No recompile needed if you hot reload. No Go knowledge required. This is the handler registry. String key on the left that matches the endpoint filter in our JSON. Handler on the right, that's the struct you built in segment 5. See the handler interface. Any struct that has a function handler with error return method can go in this map. That's it. Adding a new endpoint to the gateway is two things. Add the handler file in domain, register here, the root JSON takes care of the rest. Same pattern as the endpoint registry, but for middleware. String key match what's in the JSON middleware array. Value is the actual middleware function. Right now, we only have check token, but you could add rate limit, require admin, log request, anything you want. Then just reference it by name in the JSON config. The architecture scales without touching the core routing logic. Load routes reads every JSON file in the get folder, unmarshals them, and returns a flat slash of root struct. If you add a new JSON file for a new service module, it gets picked up automatically, no code change. This runs on every single request regardless of route. Request ID stamps each request with a unique ID, critical for tracing issue in production. Recover, catch, panics, and turn them into 500 response instead of crashing the server. CORS handles cross-origin header. These are your gateway-wide concern. This is where JSON config become actual running routes. E.add register each output. Each route dynamically. The handler comes from our endpoint name. The middleware comes from chain middleware. Let me show you that function. Let's go to the demo. First, start the backend service. This is our mock-out server running on port 50051. Think of this as the real microservice that lives inside your private network. The gateway will talk to the over RPC. Tell the gateway where to find the out service in production. This would be a real internal hostname, something like out service internal 50051. We use an environment variable so we never hardcode the address. Now start the gateway. It reads the routing config, registers all the handler, connects to the gRPC service, and start listening on port 8080. Everything we built in the last 5 segments is running now. First test, happy path. File username and password. Let's see the full round trip. Request hits the gateway on port 8080. Passes through the global middleware, handle beans and validate the body. Calls the gRPC service on 50051. Gets back a token. HTTP 400 code 200 in the body. Token is there. This is the exact shape from our response track. Code, message, data. Every successful response in this gateway looks like this. Now, wrong password. Same username, different password. HTTP 401. The gRPC service reject the credential and return an authenticated error. Our gateway code that map it to 401 and return a clean message. The client knows exactly what went wrong. Invalid credential, not value 500, not a 200 with an error buried in the body, a proper 401. Last test, remove the password. Fill entirely, don't send at all. And get response HTTP 400. And notice this never touched the gRPC service. The validator chose the missing password at the gateway level and rejected it immediately. No network call, no west resort on the backend. The error message tells you exactly which field failed and which rule it broke. Password failed the required take. Your frontend can parse this and show the user profile from error. The 3 scenarios success. Wrong credential, missing field. 2 different response code, 2 different message, all from the same consistent response shape. That's the gateway working exactly as designed. Let's look at the few things you change before taking this to production.